In this video, we'll be looking at special right triangles. The 45, 45, 90 right triangle is the first one that we'll be looking at. All 45, 45, 90 triangles will be similar because of the angle-angle similarity postulate. Any triangle that has those three angle measures will be congruent angles to another triangle with 45, 45, 90, and therefore those two shapes would be similar because of that angle-angle postulate. So we can say that because they're similar, their sides must be proportional. So the one that we use to compare all of our 45, 45, 90 triangles is the one that's drawn right here. You can see that it has two angles that are worth 45 degrees and two sides that are worth 1, and then a 90-degree angle, and across from that the hypotenuse is worth root 2. Well, when you test that out using the Pythagorean theorem of a squared plus b squared equals c squared, then we can check to make sure that that fits and why that happened. Our legs are both worth 1. 1 squared plus 1 squared would just be 2, and that would be equal to c squared. But to get c all by itself, we would have to take the square root. So the square root of 2 becomes the hypotenuse of a triangle that has two legs worth 1. So that's where that one comes from. We can use it to solve for the missing side lengths in other 45, 45, 90 triangles. So we have to verify that it is a 45, 45, 90 before we can use this method. So I'm going to take a look at this example below, and I can see that it does have a 45-degree angle marked as well as a 90-degree angle marked. So that means that this other angle must also be 45. And then because of the base angles theorem converse, so that's labeled up here as a reminder, we know that if you have two angles that are congruent to each other, then the sides across from them must also be congruent. So this ends up being an isosceles right triangle. So since 45 degrees of the original picture was across from the side worth 10, then the other side that was across from the other 45-degree angle must also be 10. So we know that the legs of this triangle are now 10. So I'm going to compare, and I'm going to put the leg over the hypotenuse for this triangle. And so my leg here is 10, and my hypotenuse, I don't know it, so I'm just going to call it x. And I'm going to do the same thing on the other side of this, and I'm going to put leg over hypotenuse. Well, I need another similar triangle to this in order to compare it. That's where this special 45, 45, 90 right triangle comes in, because we can see that the leg on this triangle was worth 1, and the hypotenuse was worth root 2. So I can plug that in and say, well, the leg is 1, and the hypotenuse is root 2. So there's a proportion comparing the triangle from up top to the triangle in this current problem. And since they're similar, we can set up this proportion to compare those sides. So now all we have to do is solve by cross multiplying like we know how to do. 10 times root 2 is just 10 root 2, and x times 1 just gets us x. So that means the hypotenuse of this triangle is just worth 10 root 2. Over in the next example, we can see that we have two sides that are being marked congruent, and one of those legs is 8. So since we have two congruent sides, the base angles theorem over here tells us that if you have two sides congruent, then the angles that are across from them will also be congruent. So since these two angles have to be the same, and there's already a right angle here, then those must also be 45 degrees. So we have another 45, 45, 90 triangle, and we can do the same thing by setting up a proportion of leg over hypotenuse, comparing this one to the original. So my leg in this new triangle is 8, and the hypotenuse is what I'm solving for, so I'm going to call it x, so 8 over x. And the leg and the hypotenuse of my original 45, 45, 90 triangle was 1 over root 2. So again, I'm going to cross multiply. 8 root 2 equals x, and that is my hypotenuse of this triangle. In the next example, we can see that we have a 90-degree angle and a 45-degree angle. And we are going to be able to say, well, since that's 45, then this one must also be 45. And therefore, these sides across from the 45s must be congruent. So this other leg is 3 root 2. So from that point, then, we can say we just need to solve for the hypotenuse. And we're going to compare it to the 45, 45, 90 triangle from above. And I'll redraw it here as a reference. The legs in that were both worth 1, and the hypotenuse was worth root 2. So we'll use it to compare. We'll put leg over hypotenuse equals leg over hypotenuse, and we'll compare it from the two triangles. So the leg in the new triangle is 3 root 2, and the hypotenuse is x. So we'll put that over x. And in the original triangle, the leg was 1, and the hypotenuse was root 2. We'll cross multiply. X times 1 is x. 3 root 2 times root 2 looks like this, and it looks a little bit messy. But when you're multiplying radicals, if they both have a radical on top of them, you can just put what the two numbers are underneath and multiply them together. So this is the same as 3 root 4. And we know that the square root of 4 is 2. So this is really the same thing as 3 times 2, which is just 6. So that became 3 times 2, and we are left with x equals 6. So the hypotenuse for this triangle is 6. Here, this time, we have a 90-degree angle, 45 degrees, so this one must also be 45. And so we know that these sides across from 45 must be congruent to each other. We don't know them, though, so I'm going to call these both x this time. And we do know the hypotenuse, so we can still compare this to our original 45, 45, 90 triangle of 1, 1, root 2, but we're going to set up a slightly different proportion this time. We'll still be able to use leg over hypotenuse because those are the sides that we know. But this time my leg is x, and the hypotenuse given to me is 12 root 2. The leg of my original triangle was 1, and the hypotenuse of it was root 2. We'll cross multiply. We get x times root 2 equals 12 root 2. So now to get x by itself, we just have to divide by root 2 on both sides. And when we do that, we can say, well, that becomes x. And this root 2 over root 2 also cancels each other into 1 and becomes 12. So our x value, or our legs, in both of this side of these triangles is 12. Then we have a hypotenuse of 6 root 2. So we've got two legs that we do not know about. And since those sides are congruent, then the angles across from them must also be congruent. So we do have a 45, 45, 90 triangle. We'll put leg over hypotenuse again. This time the leg is x, the hypotenuse is 6 root 2, and then our leg of the original was 1, and the hypotenuse was root 2. We'll cross multiply to get x times root 2 equals 6 root 2, and we'll divide both sides by root 2. So that leaves us with x equals 6. On our last 45, 45, 90 triangle example, we have a 90-degree angle and two congruent legs. That tells us that we know these are 45-degree angles. The hypotenuse this time is 18. So when I put leg over hypotenuse, my leg is x and the hypotenuse is 18. The original leg is 1 and the hypotenuse is root 2. We'll cross multiply and we're left with 18 equals root 2 times x, and we have to divide by the square root of 2. Well, the square root of 2 divided by itself is just 1, so we get x equals this. But when you have a radical in the denominator of an answer, you need to rationalize the denominator. And this is something that you should have seen last year in algebra. But as a reminder, what we need to do to get rid of that radical in the denominator is just to multiply by root 2 over itself. So when I'm multiplying by something over itself, we're really just multiplying by 1, which is why we're allowed to do this. But what happens there is we can say on top, that leaves us with 18 root 2, and in the bottom, root 2 times root 2 is the square root of 4. Well, the square root of 4 is just 2, so I'm really left with 18 root 2, and now 18 divided by 2 is 9, and our root 2 comes down. So that becomes our most simplified form of the leg lengths for both of these, so 9 root 2. So now that we've covered the 45, 45, 90 right triangle, the other special right triangle that has a similar kind of setup and rule is the 30, 60, 90. So anytime you have a 30, 60, 90 triangle, it will always be similar to the one shown here because of angle-angle similarity. And so we can still set up a proportion when it's a new side length for us that we need to solve for. These ones will be a little bit trickier than the ones we just did because there are now 3 separate sides instead of having the legs being the same. So we'll notice that the side that's across from 30 has to be the smallest. That is always 1. The side that's across from 60 will be the other leg, and that's always root 3. And the side across from the 90-degree angle is always 2. So root 3, the square root of 3, is something that is smaller than 2 because we know the square root of 4 is 2. Remember that your legs always have to be smaller than the hypotenuse as a total there. So the hypotenuse always has to be the longest side. So we're going to use this to write proportions again. We can see right away that we do have a 30, 60, 90 triangle in this example. Now, if it helps you to redraw the one from above, right below here in that same orientation, to remind yourself what the two triangles are, then that might be helpful to write a proportion. So if I orient this triangle the same way that this first example is written, the shortest leg is 1, the other leg is root 3, and the hypotenuse is 2. So I'm going to be able to solve now for my hypotenuse, which I'm going to call x, and my long leg, which I'm going to call y. So I'm going to put my short leg over my hypotenuse first. So the short leg of my triangle is 14. That's the side that was given. The hypotenuse of my triangle is x. I'm going to set that equal to the short leg over the hypotenuse of my triangle from above, 1 over 2. We'll cross multiply, and x equals 28. Then, at that point, you could either use Pythagorean theorem, or you can just do the similar setup with proportions and do the short leg over the long leg. So if I do short leg over long leg, that would be 14 over y equal to 1 over root 3, because I'm pulling from that similar 30, 60, 90 triangle over here. We'll cross multiply, and we get y equals 14 root 3. So I've now solved for my new sides. So the long leg of this triangle has become 14 root 3, and over here we have 28. So you'll notice here the pattern that this is kind of following. Well, 14 was in proportion with, or related corresponding to that side of 1. And now the side that was related to 2 is now 28. So to get from 1 to 2, you multiply by 2. To get from 14 to 28, you also multiply by 2. Similarly with the root 3, notice how they both have, the short and the long leg both have that 14 in common. So to go from 1 to root 3, you just have to multiply by root 3. So if you can see those patterns and you want to use that as like your quick way to get there, you can also do that as well. Over here, we have a 30, 60, 90 because one of the angles is already 60 and the other is 90. Since this is oriented this way, if it helps you to redraw the picture, you can add your other triangle down below. The shortest side is 1, the longer leg is 3, and the hypotenuse is 2. So we'll say hypotenuse is x again, and this long leg can be y. I'm going to put my short leg over the hypotenuse. The short leg was 4, and the hypotenuse is x. My short leg down here is 1, and the hypotenuse is 2. Cross multiply, so x equals 8. Notice there that 4 times 2 is 8. Then we have our short leg over our long leg to find out what that long leg will be. The short leg that we know is 4, and the long leg we want is y. And in our other triangle, our short leg was 1, and our long leg was root 3. We'll cross multiply, and we see that y equals 4 root 3. Again, we could have just multiplied 4 times root 3 to get there for that solution. If you think you understand and you want to try the rest on your own, pause the video and give them a try, and then press play when you're ready to review. Here we have a 30, 60, 90 triangle again. Remember, 1, root 3, and 2 is our standard that we're going off of here. So we're going to say maybe this long leg is x and the short leg is y. So I'm going to compare, let's start with doing the short leg over the hypotenuse. This time we know our short leg is y and our hypotenuse is 14. And we'll compare that to 1 over 2. Cross multiply, so 2y equals 14. We would have to divide both sides by 2 to get y equals 7. And then to solve for our x value, we're going to have to compare the long leg to the hypotenuse. Or you can compare long leg to short leg since you've just found that as well. From there, we can say the long leg is x, the hypotenuse was 14, the long leg of my original triangle was root 3, and the hypotenuse was 2. We'll cross multiply, and we get 2x equals 14 root 3. We have to divide both sides by 2, and that becomes x equals 7 root 3. Over here, we know that we are comparing this to a hypotenuse of 2, a short leg of 1, and a long leg of root 3. We'll say the short leg is x and the long leg is y. So I'm going to start with my short leg over my hypotenuse. The short leg is x, and the hypotenuse is 6 root 3. The short leg that we know in this triangle down below is 1, and the hypotenuse is 2. We'll cross multiply. 2x will equal 6 root 3. So we'll divide by 2 on both sides, and x equals 3 root 3. To get our long leg y, we can put long leg over hypotenuse. So that'll be y over 6 root 3. And we'll set that equal to root 3 over 2. When we cross multiply, we get 2y equals 6 times root 3 times root 3. Well, remember that when you're multiplying radicals, you just multiply what's underneath and put them under a radical. So this becomes 2y equals 6 root 9. Square root of 9 is 3. So really that's the same thing as 6 times 3, or 18. So we're left with 2y equals 18, and to get y, we'll divide by 2, and y equals 9. In this example, that is our long leg that is given to us, which we know is in the form root 3. Our short leg is always in the form of 1, and our hypotenuse is 2. So we'll compare and write a proportion. We can put short leg over long leg. So our short leg over our long leg will be x over 8 root 3, and we'll compare that to 1 over root 3. Cross multiply, so we get root 3x equals 8 root 3. Divide both sides by root 3, and we're left with x equals 8. Our y value here is our hypotenuse, so we want to do long leg over hypotenuse. Our long leg was given to us as 8 root 3. I'm going to put it over the hypotenuse y, and we'll compare that to root 3 over 2. Cross multiply to get root 3y equals 16 root 3, and we can divide both sides by root 3. So we're left with y equals 16. And finally, in the last example, we're going to find our short leg and our hypotenuse. We'll compare it to the 1, 2, and root 3 that we know of our 30, 60, 90 triangle. And we will say that the long leg over hypotenuse will help us out here because we know the long leg is 15. So I'm going to put 15 over y and set that equal to root 3 over 2. We'll cross multiply. Root 3y equals 30. We have to divide both sides by root 3. So we're left with y equals 30 root 3. But this is where we need to rationalize the denominator. So whenever you have a radical in the bottom of a fraction, we need to do root 3 over root 3 and multiply the top and bottom. When we do that, this becomes 30 root 3 over the square root of 9. Square root of 9 is just 3, so this becomes 30 root 3 over 3, and we can simplify that to 10 root 3. We still have to find our x value here, which is our short leg. This was the work from above. So we're going to put short leg over long leg. Our short leg is x, and our long leg is 15, and I'll set that equal to the short leg of 1 over the long leg of root 3 from the original triangle. Cross multiply and get 15 equals root 3x. Again, we're going to have to divide by root 3. So we have some more rationalizing to do. 15 over root 3 can be rationalized by multiplying by root 3 on the top and the bottom. So we'll be left with 15 root 3 over 9, the square root of 9, which is 3, and 15 divided by 3 is 5. So we're left with 5 root 3 equals x.